Okay, folks, today we are focusing in on a very specific skill with sequences. I thought about going on and doing some series stuff today, but I feel like that's stretching it given how much time we have left, today being the last day of instruction for Algebra 2. I decided instead we should probably focus in on one of these skills for sequences, which is specifically writing those explicit formulas. And in theory, we've talked about this a little bit over the last two lessons, but I wanted to do a more specific lesson geared precisely at writing those formulas for arithmetic and geometric sequences. So remember that so far in your Algebra 2 class, we've talked about two different types of sequences. Arithmetic sequences, which again is that constant addition pattern. And those always have the explicit formula written in the form a sub n, which is the nth term, equals a sub 1, first term, plus d times n minus 1, where a sub n is the nth term, and that will stay a sub n in your explicit equation. A sub 1 is the first term, which you should just pull directly from the sequence. D is the common difference, or the value that you are adding or subtracting over and over again. And n is the term number, which again, you're never going to be plugging anything in for n. N is your independent variable, and a sub n is your dependent variable. So those two will stay in the equation. Your job will be to plug in the first term and the common difference, a sub 1 and d. And then you could simplify, but you don't have to, okay? Then we had geometric sequences, which are the ones that have a constant multiplication pattern. Remember that that would also include division, because division is just multiplying by a fraction, okay? These have the equation a sub n equals a sub 1 times r to the n minus 1 power, okay? Where a sub n is the nth term. Again, you're not going to plug anything in for that. That's your dependent variable, your y. A sub 1 is the first term, which you should just be able to pull from the problem. R is your common ratio, which is the value that you are multiplying by to get each term. And n is your term number. Again, a sub n and n are going to be your variables in your explicit formula, so you're not going to plug anything in for those. You need to be able to, basically it's a two-step process. You need to identify whether it is arithmetic or geometric, and then you need to plug the common difference or common ratio and first term in to the general equation to come up with the specific equation for that sequence. So we're going to go through a bunch of examples here to show you how that process works, and then that will be it. That'll be the end of Algebra 2 instruction for this school year. Yes, you will have a Delta Math assignment over this. It will be your final assignment of the year, and it'll be due tomorrow at 3:30. Grab your screenshot if you want one. We're going to scroll on to the maybe first two examples, depending on whether or not I can fit them on the screen. Any questions before we advance? All right, here we go. So it looks like I can fit these two, so we'll do these two. All right, so again, this is basically a two-step process. Your first step is to figure out, is the pattern arithmetic or geometric? Which is as simple as figuring out whether the pattern is based on addition or multiplication. So if we look at this example, this is a constant addition pattern. So that tells us it's arithmetic, which means a sub n equals a sub 1 plus d to the n minus 1 power, or d times n minus 1, sorry. Your D value is positive 4, and your A sub 1 is 10. The first term is 10, okay? So all we have to do is plug those values in. 10 plus 4 times n minus 1. Delta Math will take that as the explicit formula. Now with arithmetic sequences, you could simplify that. You could distribute the 4 and then combine like terms. Okay, if you distributed the 4 and then combine like terms, this is an alternate form, which is also fully acceptable. It will take either answer, okay? It doesn't matter whether you give the basic form or the alternate form. It will accept either answer, okay? Both are correct. Okay, so one of those two would be our equation, our explicit formula for that sequence. Okay, so on the next one, we're looking for a pattern. That pattern is a division pattern. You are dividing by -2. Which means, since it's a division, that means that R is -1/2. We're multiplying by -1/2. Okay? Our first term is 32. And again, we're plugging into our geometric, that is a geometric pattern, because it's based on multiplication or division. So we're going to plug into the geometric sequence equation. So we plug in our R value and our A sub 1 value. That would be 32 times -1/2 to the n minus 1 power. That is the answer. We cannot simplify it. There's no alternative form for geometric. It's just that formula. Okay? So there's your first two examples. Grab your screenshot. And we'll move on to the next couple. There we go. Grab your screenshot if you want it. Basically, we've got a two-step process here. We figure out whether it's arithmetic or geometric, and then we plug into the appropriate equation. Okay, so there's one arithmetic and one geometric example. We are going to continue. I think there's 6 more examples in the notes. We'll burn through those, and then we'll call it a day. Okay, on to the next 2 examples. Okay, this next one, you'll notice that the pattern is not constant for addition or subtraction. It goes -6, -3, so it's not addition based. So it means it either has to be multiplication or division. In this case, we are multiplying by 1/2 or dividing by 2. If you recognize dividing by 2, that's the same as multiplying by 1/2. So we need to recognize that this is a geometric pattern, that the R value is 1/2, and that the first term is 12. Plug into our equation. Again, we're only going to plug in we are only going to plug in the A sub 1 and the R. So A sub n equals 12 times 1/2 to the n minus 1 power. And that's what we got right there. That's it. That's correct. Okay? Can't simplify anything. All we're doing is plugging in A sub 1 and R and calling it a day. That's the equation. On the next example, this pattern has a constant subtraction pattern to it. 9, not 8. We're subtracting 9 each step. So this is an arithmetic sequence. Our common difference is -9. Our first term is 29. And we're plugging into our arithmetic sequence equation. So that would be 29 minus 9 times n minus 1. Again, this is a fully acceptable answer. Delta Math will accept it. The n minus 1 needs to be, on the previous example, the n minus 1 is an exponent. It has to be up as an exponent. We could also simplify that by distributing the -9, which would give us 29 minus 9n plus 9, and then combining these like terms to give us -9n plus 38. Again, either one of these, they are both correct. They're equivalent equations, so it shouldn't matter which one you use. Now, that's a good question. On the geometrics, the R value has to be based on multiplication. So no, you cannot put divided by 2 in parentheses. It's got to be the multiplication pattern. So you have to recognize that division by 2 is the same as multiplying by 1/2. Okay? Whatever you divide by, that's your denominator. Put 1 over that, and that will give you your pattern. Okay? No, you have to use a fraction. You can't put divided by 2 in for R. It's got to be the multiplication pattern. Okay, 2 more examples in about 15 seconds here. If you have any other good questions, a good question. If you got any other questions, drop them in the chat to grab your screenshot if you want it. We're going to go to the next 2 examples here very, very shortly. Okay. Yeah, we'll just do the next 2 examples. Okay. So again, we look for our pattern here. Our pattern on this next problem is that we are adding 2 each time, which marks this as being an arithmetic formula. So a sub n equals a sub 1 plus d times n minus 1. Our d value is positive 2. Our a1 value is 11. So a sub n equals 11 plus 2 times n minus 1. Again, that is a fully acceptable answer. There's no reason to do anything to it. But if you choose to simplify it, that would involve distributing the 2 and then combining like terms to give us an alternate form, a sub n equals 2n plus 9. These are both correct and are both accepted by Delta Math. Okay? So you should be fine either way. On the next problem, we're multiplying by -2 each time, which makes it a geometric pattern. So again, our a sub n is a sub 1 times r to the n minus 1 power, where r is the number that we're multiplying by, in this case -2, and a sub 1 is the first term, 1. So a sub n is 1 times -2 to the n minus 1 power. Again, the number that goes in the parentheses on those geometric sequences has to be the number that you multiply by. Even if you recognize a division pattern, you have to change that into a multiplication pattern. Okay? If you're dividing by 4, that's the same as multiplying by 1/4. If you're dividing by 2, it's the same as multiplying by 1/2. So just take whatever number you're dividing by, put 1 over that, and that would be the fraction. Okay? Okay, I think there's 2 more examples. We'll go through them here very shortly. So if you've got any questions, drop them in the chat, grab your screenshot. Okay. Okay. All right. So, last two examples. Here we go. So this first one here, our pattern is we are subtracting 4 each time, which makes it arithmetic. Our D value is -4. Our A sub 1 is 15. So our nth term, A1 plus D times n minus 1, that would be 15 minus 4 times n minus 1. As with all the other arithmetics, that answer is fully acceptable. If you prefer to distribute and combine like terms, the alternate format would be -4n plus 19. These are both equally correct. Okay? And finally, on our last one, okay, once again, we have a division pattern which is the same as multiplying by 1 over 2. So this is a geometric sequence. R value is 1/2, because again, it has to be the value that you're multiplying by. It can't be the value you're dividing by. And our first term is 20. So A sub n is A sub 1 times R to the n minus 1 power. That would be 20 times 1/2 to the n minus 1. There we go, folks. We made it. We have made it through the entire school year.